Doctor en Deporte y Ciencias del Ejercicio de la Universidad de Birmingham. Posee una maestría en Fisiología del Ejercicio de la Universidad de Reino Unido. Profesor de Deporte y Salud Nutricional de la Escuela del Deporte, Ejercicio y Ciencias de la Rehabilitación de la Universidad de Birmingham. Académico y científico en estudios con deportistas élite en las áreas de deporte y salud nutricional. Posee un postdoctorado en el Departamento de Biología Integral de la Universidad de California. Sus conferencias: Nutrición para el desempeño competitivo ideal. Y la segunda conferencia es Estrategias nutricionales para optimizar la adaptación al entrenamiento deportivo. Recibimos de esta manera al doctor Gareth Wallis de Reino Unido. Un fuerte aplauso, por favor, para nuestro primer conferencista.
Good morning, everybody. Thank you for coming to this presentation. Before I start, I would just like to express my thanks to Col Deportes for organizing my trip to Colombia this week. The hospitality has been fantastic. I'd also like to thank the Colombian Olympic Committee for the opportunity to present in this meeting today. So what I've been asked to talk about is sports nutrition for optimal performance. And I'm going to have two presentations. The first one is now, which will be focused around nutrition in the acute setting of exercise competition. And the one later on this morning will be how we might use nutrition during training of athletes to try and enhance adaptation to exercise training. Have the next slide, please. Just before I start, I'll just say a few words about where I've come from. So I'm from the University of Birmingham, which is in the middle of the UK. On a sunny day, it's a beautiful site, as you can see. This is our lovely campus. If anybody is ever in Birmingham, please look me up, because I'd love to show you around this campus. Next slide. So the University of Birmingham, for those who aren't aware, is one of the oldest universities in the UK, more than 100 years old, and it was actually the first civic university, so the first free university in the UK. And we've always characterised ourselves as being pioneers in innovation, so coming up with new research questions to tackle the challenges of the day. One of the biggest examples of this, and probably relevant for this nutrition talk, is the fact that the University of Birmingham were the first to synthesize vitamin C, which has obviously gone on to have a tremendous impact in helping to correct nutritional deficiencies around the world. And this type of innovation continues till today, but increasingly we're trying to innovate on an international stage and have international impact, which is another reason why it gives me great pleasure to be in Colombia today, because it helps to move towards some of our international ambitions and collaborations. The final thing that I'd just like to say about the university is just really to read a statement, which is how we describe ourselves as at the university, and probably something that can be an inspiration to other universities. I'm just going to read this statement at the bottom. So at Birmingham we say that universities are never complete. They develop as new challenges and opportunities occur. At Birmingham we innovate, we push the frontiers of understanding, we ask new research questions, we turn theory through experiment into practice, because that's what great universities do. And that's our aspiration, is to really be a great university. So within the university, I'm based at the School of Sport, Exercise and Rehabilitation Sciences. And this is a multidisciplinary department, and we are actually the top-rated department for this field in the UK. And we have a mission, really, and that mission is really to find new ways to support the physical activity and sport needs of all individuals and communities. And this ranges from at the elite end, so the high-performance athlete, right down to trying to increase participation in sport and physical activity for those who may be desiring health benefits. So it's really quite an interdisciplinary approach, and we're organised around 5 major research themes, which are listed here: maximal performance, healthy ageing, active lifestyles, movement rehabilitation, and effective learning. And the one that I'm most interested in and concerned with is maximal performance, and this is about optimizing the performance of athletes. So just before I get into the main body of the presentation, just to further the field of maximal performance, this is one of our labs, one of our human performance labs in Birmingham, where we conduct a lot of our exercise research. And my particular areas of interest is in how we can use nutritional strategies to optimize metabolic responses in athletes, to enhance their performance. And so we look at this from a number of perspectives, measuring metabolic responses in the lab to try and create optimal situations, and then look at how this translates into the actual effect on competition performance. Okay, so my outline for today, I'm going to make a brief introduction of where I see sports nutrition, where it fits into the training process and the competition process. And then I'm going to focus specifically in this session on optimizing carbohydrate intake strategies for performance. And hopefully by the end of it, you'll realize that carbohydrate isn't just for the serious endurance athlete, but probably has a role for most sports and most athletes. And then I will just summarize some of the main points from the presentation. So we're going to start with an introduction to sports nutrition. Okay. So I've listed a lot of words up here, which reflect many different factors: genetics, medical support, organization, team management, physiology, nutrition, and that's really just so that we're all on the same level, on the same page, and understand that performance isn't just about one aspect. It integrates a number of important factors that all have to come together at the same time to result in that optimal performance. From my perspective, I'm very much interested in how the physiological aspects and the nutrition aspects influence performance. But what we mustn't lose sight of is that it's not just about physiology and nutrition. We need to have all of these things in order to maximize our performance. So if we think about the physiology of athletic performance, it really for me comes down to 5 areas, and that's aerobic fitness, anaerobic power, strength and power, anthropometry and flexibility. And different sports rely on these in different amounts, but by and large, they're the 5 things that need to be optimized for optimal performance. Now the important thing for me is actually that nutrition can impact on almost all aspects of the physiology of athletic performance. Perhaps with the exception of flexibility, that's debatable, but certainly all of these other factors can be profoundly affected by nutrition. So that gives us a great opportunity to use nutrition to improve the physiology. But as I've tried to emphasize so far, we must be careful in not overemphasizing the role of physiology and nutrition. And so this is a statement that I think is important to remember. I'll read it out because the red may not be very clear. From my perspective, good nutrition alone can't guarantee success. It doesn't substitute for training. but poor nutrition may guarantee failure. So that just puts it in context. If you don't put the hard work in, the nutrition isn't going to help you. But if you put the hard work in and don't pay attention to nutrition, then actually you may not reap the benefits of your hard work. So sports nutrition is evolving and continues to evolve, and I just want to outline where I see the kind of current position and concepts in sports nutrition. So this is a classical perspective on the physiological contributors to exercise performance. Typically, we have a number of exercise parameters that we could modulate: the duration of training, the intensity, the frequency, and the recovery, and this all provides a training stimulus. And we seek to optimize that training stimulus to adapt physically to enhance our performance. Now, nutrition, classically, and this is what I'll talk about in the first part of the presentation, classically we think of nutrition as something that we can acutely use to optimize a single competitive performance, okay? And that's the traditional view, most obviously seen when you think about endurance sports and consuming large amounts of carbohydrate for optimal performance. And I think as a result of this, optimizing the acute competition performance, what we've often thought of is that, well, if we can optimize performance by nutrition here, well, we really need to use the same strategies in training so that we can increase the intensity or the frequency or accelerate recovery to get the optimal training stimulus and the optimal physical adaptation. And there's still some truth in that and some value in that. But I think what I'll show you over the course of the morning is that actually there may be some value in having suboptimal nutritional preparation during the training period in order to actually get the most optimal training stimulus. So that's a bit of a paradigm shift, which I'll talk about in my second presentation. And the second area where the current concepts are developing are that actually we can use training to get a stimulus for adaptation, and we can also think about now using nutrition to enhance that stimulus to get a further adaptation. And again, I'll talk about that in the second presentation. But today this morning I'll focus on optimizing acute nutrition for exercise performance, so a competitive event. And then the final thing around current concepts in nutrition is that I think our traditional focus on sports nutrition has been around the muscle. How do we optimize the condition of the muscle and the amount of fuel in the muscle to perform optimally? But what we're starting to learn in the last 10 years is actually that nutrition goes beyond muscle, and it really is an integrative process that involves processes of digestion, absorption, and the effects on the liver and the muscle. And increasingly we're beginning to learn about the role that the brain plays and how nutrition can help to optimize the status of the brain, which is the ultimate controller of motor output and muscle recruitment. And so we're now looking at nutrition from a much more integrated perspective rather than just thinking about the muscle. Okay. So hopefully you will recognize all of these performers, and I picked them off some of the websites, and it shows some of your very successful Olympians in 2012. And the reason I highlight these individuals is because they represent a tremendous range of sports. So you have these very explosive sports which involve sustained, high-intensity activity, but also very prolonged endurance-type activities. And that's an important thing to take into account when you're thinking about sports nutrition, is that performance means something different for different athletes, and that presents challenges in terms of trying to provide the optimal strategy, because they may all require slightly different approaches. Okay, thank you. So Before I start talking about carbohydrate, just as a follow-on from the previous slide, showing this breadth of the type of events that we have to deal with, I've just presented some of what I see are the challenges in sports nutrition. And I don't necessarily have all of the answers, but I think they're things that we should bear in mind as we try and develop strategies for athletes. No sport is the same and no athlete is the same. So the requirements based on the sports maybe differ, and actually each individual athlete may have different preferences and may respond differently to different approaches. So that needs to be taken into consideration. From a scientific perspective, which is very much the angle that I come from, we know a lot about some sports and some events, typically the ones that are easiest to study, and we know very little about other sports. And in those situations, we're often having to take information from sports that we do know and translate that to sports where we know relatively little about. And there's a degree of risk in that, and so we need to take that into account. Another thing which I think is of primary importance for when we're talking about high-performance athletes is that it's very difficult for me as a laboratory scientist to bring in an elite athlete and actually do the types of experiments that I would like to do with them. So we're often experimenting with sub-elite athletes. And it may well be that in some situations their responses to nutritional interventions aren't always the same as that you would get with an elite athlete. So when we prescribe recommendations, again, we are taking a risk that they may not be designed for the elite athlete. But by and large, with a sensible approach, we should be able to use most of that information. And the other thing that I think is very important, and I'll express a number of guidelines today, but one thing that has to be clear is that implementing these strategies and these guidelines that are often developed in laboratory conditions and translating them into practical situations in the field isn't always easy. So it does require a degree of trial and error with athletes before finding the optimal approach. Okay, so what I want to do in the main part of the talk is really emphasize the role that carbohydrate may play in different aspects of performance, and we typically think about carbohydrate in the context of pre-exercise, during, and in the post-exercise recovery. And what I'm going to try and do is bring you up to current thinking on the role of carbohydrates, because there's a large established body of literature in this area. But what we have seen in the last 10 years is actually some significant advances in our understanding in this field. So I think it's an area that continues to evolve. So if we're thinking about the effects of carbohydrate and why we're trying to consume carbohydrate, we know that it's an important fuel for physical activity. And in the lead up to an exercise bout or a competitive event, really in the days leading up, it's about ensuring that we have sufficient muscle glycogen levels, which is the main fuel utilized during exercise. And then in the morning or on the day of performance, it's really about topping up our liver glycogen stores, because when we're asleep, we'll be using our liver glycogen to fuel the brain, and therefore in the mornings we need to replenish that, because the liver glycogen provides the source of glucose for the brain. Okay, looks like one of the slides hasn't come out very clearly here, but this slide is really to emphasize some very old literature taken from the 1960s in Scandinavia, which really made a significant contribution to our understanding of how carbohydrate can affect exercise performance. And in this context, it's prolonged endurance performance. And I'll just refer to the graph on the right-hand side in this case. And what it shows is this is time to exhaustion, so how long athletes could cycle for at a fairly high intensity, about 70% of their maximum. And this is the level of muscle glycogen, so the amount of carbohydrate fuel in their muscles before they started the exercise bout. And what we can see is that there's an essentially linear relationship between the amount of carbohydrate in the muscle and the time to exhaustion. And we know that we can manipulate the level of carbohydrate in the muscle by changing the amount of carbohydrate in the diet. And in this particular study, In the red here, these individuals were on a low carbohydrate diet. In the yellow, a moderate, and in the green, a high carbohydrate diet. So we have known for more than 40 years that having a high carbohydrate diet can increase muscle glycogen stores and increase the time to exhaustion in endurance events. Now, one of the follow-on approaches from this was to introduce what I would call fairly extreme strategies, whereby athletes would seek to maximize their muscle glycogen stores, and this would involve often very arduous exercise to deplete the stores, and then reverting to initially quite high-fat diets, then followed by very high carbohydrate diets to super compensate the muscle glycogen stores. And it became very clear that these approaches are not very practical for athletes and can be very uncomfortable. Okay, so it looks like another slide hasn't come out, but I can talk you through it. This was a graph that was really designed to show that there's a very nice study in 2002 which showed that actually, rather than having to go through some very extreme carbohydrate loading practices in the days before and the week before a big event, a big endurance event, you can actually just have one day where you do no exercise and have a very large amount of carbohydrate intake, and we're talking 10 to 12 grams per kilogram body mass. And that's sufficient to induce what we would call a glycogen supercompensation, so to really elevate those muscle glycogen stores. Okay. And so rather than having to have these extreme diets for a number of days, we now have a very clear recommendation. And that is written up here. So for events lasting greater than 90 minutes, so we're really talking about endurance events here, carbohydrate loading at 10 to 12 grams per kilogram body weight per day for 1 to 2 days before an event will provide a sufficient optimization of carbohydrate availability around that acute performance bout. So you will be in the correct state for an endurance performance. Now we're back to this picture again with our diverse range of sports and athletes, because that approach that I talked about previously may be suitable for the prolonged endurance cyclist, but in these types of events, fatigue isn't really associated with a complete depletion of muscle glycogen stores. So we might say, well, do we really need to have these super compensated glycogen levels for these types of athletes? And the answer is probably no. We don't need to have a super compensated muscle glycogen store, but we should still ensure that there is adequate glycogen, because it's still a very important fuel for muscle contraction. And as I'll show in the next slide, there are some important roles of muscle glycogen beyond energy provision as a fuel, and particularly in controlling muscle function, that may be equally important for these type of events where explosive activities are required. So if we're thinking about guidelines and recommendations for non-endurance type sports, the carbohydrate is still important, but actually loading is not necessary. But I would call it general fueling up, having adequate energy availability. And really you can achieve that with around 6 to 10 grams of carbohydrate per kilogram body weight. And so you can do the maths to multiply that up for an athlete for 1 day prior to competition. And that's just recommended for these types of athletes to ensure high carbohydrate availability for their sports. Okay. Seems there has been some transition issues between my presentation. But what I want to show here is just why the carbohydrate availability is still important for these athletes that have an explosive nature in their sports. And we're learning more and more about this as research continues. But in the last few years, we've started to learn that the glycogen in the muscle also has a role in affecting the excitation, contraction, coupling processes. So the actual processes that lead to muscle contraction. Okay, and when you have low levels of glycogen in particular regions of the muscle, then these processes are affected and muscle function is reduced. And so in the context of an explosive event such as a weightlifting or a triple jump, you can imagine that if there are suboptimal levels of glycogen, particularly around in type 2 fibers that are recruited for these explosive movements, then the function of those fibers may be affected, and therefore the explosive capability may also be affected. So I think what we're learning more and more about now is that glycogen has an important role not just in providing fuel for endurance, but also in regulating muscle contractility and maximal muscle performance. So that's why I think there's some justification for the explosive athletes to ensure adequate glycogen availability. Okay, so in terms of carbohydrate intake on the day of performance, but still before the performance here, the general guideline, and I've articulated this in a recent review that's available as open access, so everybody should be able to read this for free in the International Journal of Sports Nutrition and Exercise Metabolism. The guideline for before exercise is a meal containing carbohydrate between 1 to 4 grams per kilogram body weight, but relatively low in protein, fat and fiber, because they can lead to gastrointestinal distress, which can have a negative impact on performance. In general, we don't typically, for performance, distinguish between whether these carbohydrates should be high glycemic index or low glycemic index carbohydrates. But if there are situations in competition where carbohydrate is not freely available in the form of sports drinks or bars or gels, then it may be prudent to consider low glycemic index choices to allow a more sustained release of glucose through the competitive bout. Okay, so I just want to move on to the carbohydrate feeding during exercise, which is one area that I've invested a large amount of time in terms of research, and I think in the last 10 years we have seen some really interesting developments. Okay, so if we look to the bottom of this slide, to understand what carbohydrate feeding during exercise is about, well, it's really about traditionally about providing an alternative source of carbohydrate to help to offset the reduction in liver glycogen and muscle glycogen stores that do occur during exercise. So it's an additional fuel source, and we often think of it in that way, and that's still true, but what I'll show you is that there are also some novel roles for carbohydrate in the context of exercise performance as well. Okay, so carbohydrate ingestion during exercise. This is a classic study from Professor Ed Coyle at the University of Texas in the mid-80s, where he really showed the fundamental role of feeding carbohydrate during endurance exercise and the effects on performance. The first thing I want to say is that they had trained cyclists who performed 2 trials riding to exhaustion at about 70% VO2 max. One, they consumed carbohydrates, large amounts of carbohydrates, and on another trial they consumed a placebo. When they consumed a placebo, they could exercise for 3 hours. When they consumed the carbohydrate, they had an extension in performance of about 1 hour. So it's quite a substantial increase in performance through a simple nutritional intervention. In terms of the metabolism associated with this, it was very much observed that the feeding of the carbohydrate helped to maintain blood glucose levels, and we know that low blood glucose is associated with reductions in performance, and it also allowed a maintenance of the rate of carbohydrate oxidation, which is the use of carbohydrate as a fuel. And we know that high-intensity exercise relies on carbohydrate oxidation and utilization, and so as we deplete our energy stores, we can't maintain that rate, and providing the carbohydrate allows a readily usable source of energy to maintain fuel production and muscle contraction. And in this particular study, they observed that actually the carbohydrate wasn't sparing muscle glycogen. Most likely it was sparing liver glycogen. But some studies have gone on to show that there may indeed also be muscle glycogen sparing in type 1 fibers during exercise with the carbohydrate feeding. So this is just to show some of the classic work that has really dominated our thinking in sports nutrition for 20 years until I guess about 10 years ago. So what's new? Well, in my mind, there's been two major developments in the area of carbohydrate feeding in the last 10 years, and thankfully I had the opportunity to be in a lab in Birmingham where most of these developments were discovered, if you like. So it has been a great privilege to be part of this. The first one is around the role of oral carbohydrate sensing and how the brain may influence exercise performance. And the second one, which I've spent a lot of time working on, is around the role of using multiple carbohydrates, multiple transportable carbohydrates, to increase the absorption of carbohydrate in the intestine to provide more fuel to the body. I'm going to talk about each of these areas. Okay, so if we start with the carbohydrate sensing. This is a really interesting study from my former advisor, Professor Asker Jørkendrup, in 1997. And he actually studied cyclists performing a 40-kilometer time trial. So it's around about an hour of activity. And that situation is not typically limited by a reduction in glycogen availability. So you can perform this and still have fuel left. But what he noticed that was interesting was that when he fed carbohydrate to these athletes during exercise, they had a significant reduction in their time to complete a task. So a reduction here is an improvement in performance. And for him that didn't make any sense. If carbohydrate isn't limiting, then why would it improve performance? So many years later, when Asker moved to Birmingham, one of his PhD students, Jimmy Carter, took on this idea and said, well, if you increase carbohydrate availability, why is it seemingly increasing performance? And they decided to increase carbohydrate availability by infusing glucose directly into the circulation, because then they could disconnect any effects of the mouth and absorption and just simply look at, if you provide lots of fuel, does it improve performance? And what you can see quite clearly here in a 1-hour time trial is that there's absolutely no difference between infusing glucose or infusing saline. So this is a strange one, because if you consume glucose, you have an improvement in performance. But if you infuse glucose, you don't have an improvement in performance. So something's going on, perhaps proximal of the circulation, to help regulate performance. So this was followed up by Jimmy Carter in a subsequent study where they decided to test the hypothesis that there may be something to do with the mouth and how carbohydrate is received in the mouth and the effects that may have on the brain and subsequent performance. So they had a study where they had athletes rinse a carbohydrate solution, and this was a non-sweet carbohydrate solution, a maltodextrin, in the mouth, or they rinsed a placebo, and they were performing the same type of time trial performance. And these are the results. When you rinse the carbohydrate, you get exactly the same performance improvement that you get when you consume the carbohydrate. And of course, this is absent when you just infuse. So this has led to the hypothesis that there may be something about oral sensation of carbohydrates in the mouth that may help to improve exercise performance. So what does that look like? Well, if we think about exercise, when we're exercising hard, we have a number of negative pieces of information that are being generated by the muscles and the joints, negative information feeding back to the brain. And the brain has to integrate this information, and the role of the brain is obviously to regulate power output. So it sends the signals that allows your muscles to contract. But if it's receiving lots of negative information, then it will actually slow down those signals and say, hold on, let's stop, because I'm getting fatigued, I'm going to get my body into a position where it's not safe anymore. Now, one of the things that we think is happening is that when you consume some carbohydrate, there may be oral receptors in the mouth that may send positive signals to the brain to let the brain know that there will be some energy coming. And so the brain knows it's going to get some energy, and it will then allow itself to self-select higher power outputs and allow the athlete to perform at a higher intensity. And there's been a number of studies that have confirmed this mouth rinsing effect over the last few years, and also some studies that have started to look at how swilling carbohydrates in the mouth leads to activation of certain areas and regions of the brain that are associated with pleasure and reward, which may provide some mechanistic insight into what's going on there. So this is an area of still in development, but I think it's a very interesting one and something that has a practical implication, which I will come on to later. But in its simplest terms, it does suggest to us that even in those short duration events, there could be a role for carbohydrate. Okay, so what about multiple transportable carbohydrates? So when we're consuming carbohydrate during endurance exercise, what we're actually wanting to do there is absorb the carbohydrate and utilize that carbohydrate for energy. So it provides a fuel source that can help offset the breakdown of our body's endogenous or existing fuel stores. And the term that we use for the use of an ingested carbohydrate source is exogenous carbohydrate oxidation. So that's the oxidation of carbohydrate that's come from an external source. Okay. And back in 2000, a very nice review was performed to look at all of the studies that have measured exogenous carbohydrate oxidation in relation to the dose of carbohydrate consumed. And this is what this graph is showing here. And put very simply, we have a number of different types of carbohydrate, and they've been plotted on a graph in relation to the dose of ingestion and the amount of carbohydrate that's actually oxidized. And what you can see, you have essentially a dose-response relationship between the intake of carbohydrate and the oxidation, up to around about 1 gram per minute. And then actually, as you start to increase your ingestion rates in ingesting very large amounts of carbohydrate, you don't seem to be able to get any higher. So something is limiting the ability of an ingested carbohydrate source to be used for the burning of energy. So we got very interested in this in 2003 when I started my PhD in thinking about what's limiting the oxidation of ingested carbohydrate. Can we increase it? And if we can increase it, does it lead to a better performance of the athlete? So this is some basic nutrition, and these are the different types of sort of dietary carbohydrates that you can have. And by and large, most of the sports drinks that are on the market typically contain mainly glucose or glucose-based carbohydrates as the carbohydrate source. But we became interested in fructose for this reason, because we theorized, and on the right-hand side of the graph we have a cellular representation of the absorption of carbohydrate in the intestine. And what we know is that glucose, which is here, is absorbed through this red transporter, which is the glucose transporter, into the bloodstream through the epithelial cell. Okay. Now, we reasoned that when you ingest larger and larger amounts of glucose, that perhaps there is a saturation in this transporter such that you can't actually get any more into the bloodstream. Now, fructose is another monosaccharide but actually is transported through an alternative transporter. So the theory is that if you provide a large amount of glucose and co-ingest fructose alongside that, then potentially you could actually increase the total delivery of carbohydrate to the circulation. I'm just going to show you one of the studies we did in this area, which is one of my PhD studies from a few years ago, to show how we did a proof of concept test of this. And so we had athletes cycling for 2.5 hours, and they consumed on one occasion a large amount of maltodextrin, which is glucose polymers. So when they're hydrolyzing the intestine, it's just essentially absorption of glucose. And on another occasion, they had a large amount of maltodextrin, but a third of the maltodextrin was replaced with fructose. And what we can see here, this is time, and this is the oxidation, so how much fuel is being burned from that drink. The blue is the maltodextrin, or the glucose trial, and you can see that it increases over time and reaches around about 1 gram per minute by the end. Now, if we look at the red bars, we can see that when we replace a third of the maltodextrin with fructose, we have a significantly increased rate of oxidation. And interestingly for us, we start to see that we can break this 1 gram per minute barrier. And in this particular study, the actual increase in fuel oxidation from that drink was about 40%. So that's quite substantial. There's probably a dozen of these studies now showing that this phenomenon is true, and there's several studies now that have been able to show that the performance effect of this is significant as well. So if you actually put athletes in a prolonged endurance time trial situation, they will perform better when they have these combined or multiple transportable carbohydrates versus a single transportable carbohydrate like a glucose. I just wanted to highlight something else here that in the context of this area of multiple transportable carbohydrates, and that's really the role of the gastrointestinal tract. And you'll remember at the beginning I said that the GI tract is a site where we're becoming to learn more about how we can optimize it. So for example, with these different transportable carbohydrates, but it's also something that we're beginning to learn that discomfort in the GI tract can also be a significant determinant of performance. It kind of makes sense. If you're not feeling very well in your stomach and intestines, you're probably not going to have an optimal performance. But the science is really only just starting to catch up with this. And this is a nice study from David Rowlands, who is in New Zealand. And what he sought to do was to take this concept of multiple transportable carbohydrates and play around with the ratios of glucose and fructose to see what's the optimal ratio. We always worked with a 2-to-1 ratio in Birmingham. But he hypothesized that maybe there's a more optimal ratio. So he had 3 conditions where cyclists performed exercise, and then they had an exercise test to exhaustion, so a performance trial at the end, and they had different ratios. So they had the 2-to-1 ratio, which is what we traditionally used, 1.25 to 1, and a 0.8 to 1. And the upshot really of this is that it seems that the optimal blend, if you like, for carbohydrates, if you're having multiple transportable carbohydrates, is a ratio that's approaching unity, so somewhere between 0.8 and 1.25 to 1. And the reason for that is you can see that on the 1.25 ratio, you get the highest exogenous carbohydrate oxidation, so you get the highest metabolic benefits. You also get the highest power output, so the performance is best. And actually, the relative gut comfort is high. So gut comfort being high means that the athlete's gut is feeling comfortable. Okay, whereas with the 2-to-1 ratio, it was the lowest. So what this tells us is that actually, we can manipulate the carbohydrates to get metabolic benefits, but also we can manipulate the ratios, try and get a handle on what's the optimal gut comfort for an athlete as well. And we know that gut comfort is an important determinant of performance. Okay, so that was, I guess, a very large portion of scientific information, but how do we distill all of this into something that makes sense for an athlete? So this is my interpretation of what our guidelines are for athletes, and much of this is based on the work that went on in Birmingham over the last 10 years. So this is time across the top, and hopefully the animations are going to work. So, okay, that's good. So if you're performing exercise up to 45 minutes, you probably don't need any carbohydrate. Okay? And that's really because the actual fuel demands aren't important enough, particularly if you've had a good carbohydrate meal before exercise. If you're performing exercise between 45 and 75 minutes, the recommendation is that small amounts of carbohydrates may help to improve performance. This may be 10 to 15 grams per hour, small sips, but increasingly it may also be that mouthwashing alone is also sufficient. If you're performing endurance exercise in the region of 1 hour to 2.5 hours, then consuming carbohydrates at the rate of between 30 and 60 grams per hour is what's recommended. And if you're performing what we would term ultra-endurance exercise, which has multiple definitions, but in this context we're talking about exercise of 2.5 to 3 hours and beyond, then the recommendation is to consume up to 90 grams per hour of carbohydrate. And there's an important distinction to be made between the types of carbohydrates that may be suitable for this range, the endurance, versus the types of carbohydrates that may allow you to consume up to 90 grams per hour. And that's really that in this range, glucose polymers like maltodextrin and sucrose are a sufficient type of carbohydrate to reach those intakes, 30 to 60 grams. However, if you want to achieve large intakes, which are very relevant for very prolonged exercise, then it's not advised to try and achieve it from glucose or single carbohydrate sources alone, but the use of these multiple transportable carbohydrates will allow the absorption processes to be maximized so that you can actually achieve these. If you try and achieve this with glucose alone, then the likelihood is that there will be some gastrointestinal discomfort. And one caveat to this is that these are very large amounts of carbohydrate to consume, so we would never try and do that for the first time during competition. You should try and train the athletes to build up to being able to consume this amount. Okay, I just want to finish on the during exercise with one thing, and again, I'll just explain it to you because the slide hasn't come out. Now, I advised for exercise below 45 minutes that no carbohydrate is necessary, and that is consistent with the majority of the scientific evidence. But there has been some recent research that has actually shown that again, just swilling carbohydrate in the mouth can actually lead to enhanced corticomotor excitability, so the ability of the brain to drive muscle function. And so I can't really show you the graphs here, and they would have been quite a nice representation. But what this study in 2010 was able to show, that mouth rinsing was able to facilitate power output during an explosive movement. So the practical interpretation of that might be that perhaps swilling some carbohydrate before an explosive bout wouldn't be a bad recommendation for those athletes involved in these explosive type events. Okay, so I want to finish on talking about the recovery period. This is an old graph from Dave Costill from 1971, and it really shows the patterns of glycogen depletion and repletion over a series of days where intense exercise was performed with a high or a low carbohydrate diet. And I'm only showing it really just to emphasize, and the yellow is the high carbohydrate diet, that if you're exercising on a daily basis and you follow a high carbohydrate diet, then you can adequately recover your carbohydrate stores by and large, okay? So the general recommendation is if you have 24 hours to recover, then assuming a generally high carbohydrate diet should allow you to restore your carbohydrate stores. Now, where recovery nutrition becomes quite important is if you have events where there are exhaustive exercise and you have to do multiple bouts on the same day, or maybe you have an evening event and then you've got something the next day in the morning where there's a small window where you have to try and optimize your nutritional intake. And that's what I'm going to focus on here. There's a number of things you can do to optimize intake in the few hours post-exercise. Some things are well established, so I'll fly through them if you like today, and then I'll just focus a little bit more on some of the new ideas around the type. So we know that the timing and the amount and the combination with protein can be ways to increase glycogen synthesis. So these two graphs will talk about the timing and the amount. This is an old study from John Ivey, which just shows that when you deplete the muscle glycogen through exhaustive exercise, if you consume carbohydrate immediately after exercise, you have very large increases in muscle glycogen synthesis. And that's what you're trying to recover in terms of short-term performance recovery. If you don't consume carbohydrate immediately, then you have very low levels of synthesis. Okay. If you delay carbohydrate intake for 2 hours, you actually have the same rate of synthesis as if you hadn't consumed carbohydrate. So the advice there is that consumption of carbohydrate early in the post-exercise period will lead to rapid increases in glycogen synthesis. In terms of the amount, this is just a study from Luc van Leeuwen from Maastricht University in Holland, and this just shows that if you consume 0.8 grams per kilogram body weight per hour after an exercise, you can have a glycogen synthesis rate of around about 17 to 18 millimoles per kilogram dry muscle per hour. If you increase the intake to 1.2 grams per kilogram of carbohydrate, you get a substantial increase. It doesn't seem that if you go above 1.2 that it can go any higher than that, but the point is there is a dose effect when it comes to carbohydrate intake. So early carbohydrate feeding and consumption of carbohydrate at regular intervals in the first few hours after exercise, so we're talking every 20 to 30 minutes, will help to optimize the rate at which glycogen can be resynthesized. And the other thing that often comes up when we talk about recovery is what role does protein play? If we're talking about post-exercise glycogen synthesis, the role is quite clear. This is a study again from Luc van Leeuwen in Maastricht, and they show that if you have the 0.8 grams of carbohydrate, you get the same rate of glycogen synthesis in the previous slide. If you add some protein to this, you get a higher rate of increase. Okay, so if you add some protein, 0.4 grams per kilo, you get an increased rate of synthesis, and it's probably related to higher insulin stimulation from protein, which drives glucose into muscle to facilitate glycogen synthesis. However, if you simply give more carbohydrate, you also get this higher rate. So the way we look at this in terms of guidelines is that protein may be an important component of muscle glycogen synthesis and recovery if your carbohydrate intake is suboptimal. But if you have high rates of carbohydrate intake, protein isn't important for glycogen synthesis. Now in a practical context, it's probably more comfortable to try and have a mixed meal rather than just having really high carbs. So maybe protein has a role, and as I'll explain later on today, that protein also has a role in muscle reconditioning as well. Okay, so the main area that I think is developing in terms of carbohydrate and recovery nutrition is the types of carbohydrate. And what we generally know is that things such as glucose and sucrose and glucose polymers seem to be the most effective for resynthesizing muscle glycogen. Fructose is a poor stimulator of muscle glycogen synthesis because it's predominantly metabolized in the liver and stays in the liver as opposed to getting to the muscle. But what we were interested in during my PhD was taking some of these concepts around increasing absorption. If we can increase the absorption of carbohydrate through glucose and fructose, we see effects during exercise. Can we also enhance muscle glycogen synthesis after exercise? So we conducted a study to look at this, and it was a muscle biopsy study. Those who haven't seen these things, this is a muscle biopsy needle which gets plunged into the muscle, and we get a nice bit of tissue that we can analyse glycogen concentration in, and this is just some fat to show you how unpleasant fat looks in muscle. So I just want to show you the final result from this study where we looked at combining glucose with fructose compared to glucose alone on muscle glycogen synthesis in recovery. And what you can see here, this is glucose and fructose. Absolutely no difference whatsoever. It's very disappointing for a PhD student to get no differences here. But what we hypothesized here was that actually they were equally effective, so it wasn't any worse with the fructose. But what's happening to the fructose? Maybe it's going to the liver, and that's also a good thing for recovery, because the resynthesis of liver glycogen is an important part of being able to maintain glucose availability in subsequent bouts. And actually, there was a follow-up study from this performed by another group in Switzerland, and they were able to show that if you combine a glucose source, this is maltodextrin, with fructose, you do get this significant enhancement of liver glycogen synthesis compared to glucose alone. So it does seem that the excess fructose that's being incorporated into that product, or that drink, does increase liver glycogen synthesis, and that can also be beneficial. So this has led us to hypothesize recently that for optimal, and I'm talking about total body carbohydrate storage in recovery, you should ingest a carbohydrate type that undergoes predominant liver metabolism, so that's a fructose or a galactose, alongside a glucose source, which can be directly incorporated into muscle. Just going to summarize. Okay, so I just want to summarize hopefully what I've told you today, this morning. We're beginning to appreciate the integrated role of the brain, the central nervous system, the intestines, the liver and the muscle in the context of sports nutrition, and that helps us inform new strategies to try and improve performance. As a result of this, the types of strategies that we've been advising to athletes is evolving. New methods, efficient methods for carbohydrate loading, novel mouth rinsing approaches, and the use of multiple transportable carbohydrates during exercise, and maybe after exercise as well. One thing that I think is important for me to emphasize, and this is what I truly believe, that there's probably a role, and I hopefully convinced you, there's a role for a well-developed carbohydrate nutrition strategy in most sports. And I don't mean over-nutrition here, I don't mean giving as much as is possible, I mean tailored and well-developed. But when we're developing these strategies, they should have the sound theoretical basis, be specific to the sport and the athlete, be realistic and practical, be rehearsed before competition, and also be considered alongside other performance determinants that are highlighted at the beginning of the presentation. It's important to remember that, as I said, good nutrition doesn't make an athlete, but it can break an athlete if it's poor. And with that, just like to say thank you again for the invitation to present. Thank you for your attention.